Hi, in this video we go through a solved problem on gravitation. A typical problem where some masses are placed at the corners of a triangle and there is an additional mass placed inside the triangle. In this problem, there is a centroid which is equidistant from the three vertices, and at that centroid a 4 kg mass has been put, and we have to find out the net gravitational force acting on the 4 kg mass. So we draw the triangle in a more detailed way and we create an x and a y axis. The y axis is vertical, it passes through A as shown. The x axis is horizontal, and the right hand side is a positive x and the left hand side is a negative x. The origin is at the centroid. So the mass at O is pulled in three directions. It's pulled upwards by the mass at A, it's pulled downwards and sideways by the mass at B, and it's pulled downwards and sideways by the mass at C. The orange arrows show the three directions in which the 4 kg mass is being pulled. And that's why we had to find the net force acting on that. So let I be the unit vector along OB and OC and J the unit vector along OA. So if you draw the triangle in a more expanded manner, we can see that OB is minus I because it's downwards and sideways on the other side, and the vertical is minus J sine theta because it's below the origin, and the horizontal portion OP is minus I cos theta because it's on the left hand side of the origin. Similarly, for the right hand triangle, you get plus I cos theta, which is on the right hand side of the origin, but minus J sine theta remains. With that, we find the force of attraction of O towards B as g m1 m2 by r squared into the vector addition. And the vector addition here is minus I cos theta plus minus J sine theta, which are the arrows shown in the triangle on the previous page. So resolving all that, we get 5g into minus I cos 30 plus minus J sine 30. Similarly, if we do FO to C, the force of attraction is again gm1 m2 by r squared, but here we have plus I cos theta as shown in that triangle on the right hand side, and minus J sine theta remains because it's downwards. So finally we will get 5g into plus I cos theta plus minus J sine theta. You can go through this in more detail. Lastly, the mass at O is pulled upwards towards the vertex A. Here we don't have any I, but we have a J unit vector. So the force of attraction of O towards A is gm1 m2 by r squared into J, which works out as 5g into J. So now we have to add all these things. The net force acting on the 4 kg mass is FO to B plus FO to C plus FO to A. And we add all that. And while adding, you can see that we can bundle together the I cos 30s. So when we bundle that, we get 5g to minus I cos 30 plus I cos 30. That becomes 0. The second term becomes 5g into minus J sine 30 minus J sine 30. That becomes minus 2J sine 30. But sine 30 is half, so that becomes minus 2j into half, which is minus 1 into j, which is shown on the screen. Therefore, the whole thing simplifies to 5j into minus j plus 5g into j, which all cancel each other out, and we get the net force as 0. Therefore, the conclusion is the net gravitational force of attraction on the 4 kg mass placed at the centroid is 0. I hope this was useful to you. Thanks and have a great day.